Assalamu alaikum wa rahmatullahi wa barakatuh, dear students. In this video, we are going to explain the last lesson in chapter 4, probability. Probability is how likely something is to happen. Many events cannot be predicted with total certainty. The best way we can say is how likely they are to happen using the idea of probability. For example, tossing a coin. When a coin is tossed, there are two possible outcomes, head or tails. We say that the probability of the coin landing a head, each head, is half, and the probability of the coin landing tails is half. Throwing dice, like this one. When a single die is thrown, there are six possible outcomes: 1 or 2 or 3 or 4 or 5 or 6. So the probability of any one of them is 6. In general, probability of an event happening equals number of ways it can happen over total number of outcomes. Example: the chances of rolling a 4 with a die, so the number of ways it can happen 1, so there is only one face with a 4 on it, and total number of outcomes 6, as there are 6 faces altogether. So the probability of rolling a 4 equal 1 over 6. Another example: there are 5 marbles in a bag, 4 are blue and 1 is a red. What is the probability that a blue marble gets picked? So the number of ways it can happen 4, as there are 4 blues. The total number of outcomes is 5, so there are 5 marbles in total. So the probability that a blue marble gets picked is equals 4 over 5 equals 0.8. As the chart on the left shows, probabilities range between 0 to 1. If an event is impossible and will never occur, the probability is 0, impossible. If an event is absolutely certain to occur, the probability is 1. Otherwise, the value of a probability is between 0 and 1. Example: a fair die is rolled and outcome noted. Determine whether each of the following outcomes is certain to happen, certain not to happen, likely to happen, likely not to happen. So rolling a 2 is probability is 1 over 6, likely not to happen, as is small the probability. Rolling a number less than 3, probability is 6 plus 6, so is equal to 2 over 6, likely not to happen. Rolling a 1 is not possible. Rolling a 7, not possible, certain not to happen. Rolling a number less than 10, certain to happen. Rolling a number greater than 1, probability equal 5 over 6, likely to happen. Rolling a factor of 6, 1, 2, 3, 6, so probability equal 4 over 6 is likely to happen. Rolling a number that is an integer, certain to happen. Rolling a negative number, certain not to happen. Log possible rolls may be 1, 2, 3, 4, 5, 6. Now, some words have special meaning in probability. Experiment. Experiment is a repeatable procedure with a set of possible results. Example: throwing dice. We can throw the dice again and again, so it's repeatable. So the set of possible results from any single throw is 1, 2, 3, 4, 5, 6. Outcome is a possible result of an experiment. So example: getting a 6 in throwing a dice is this is outcome. Now, when dealing with probability, every experiment has a set of possible outcomes called the sample space. Probability is focused on the chance of one particular event from the sample space occurring. If an event has only one possible outcome, the event is called a simple event. If an event has more than one possible outcome, the event is called compound event. Sample space. A sample space is the set of all possible outcomes for of an activity or experiment. For example, activity or experiment tossing a coin. The sample space as a list, there will be two outcomes in the sample space, heads or tails. In activity or experiment rolling a die, there will be 6 outcomes in the sample space, 1, 2, 3, 4, 5 or 6. Rolling a pair of dice, 2 dice, there will be 36 outcomes in the sample space, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6, 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6, 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6, 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. An event is a subset or a portion of the outcome in a sample space. Examples: an event could be rolling a 5 with a die, we can call it an event. An event could be rolling a number less than 4 with die. An event could be tossing a head on a penny or a coin and rolling a 3 on a die. A simple event is an event that consists only of a single outcome. There is only one outcome answer in the sample space. Example: probability of rolling a 4 on a die has only one outcome. Probability of flipping a coin and getting hits has only one outcome. Probability of flipping 2 coins and getting hits has only one outcome. A compound event is a combination union of 2 or more simple events. There will be more than one outcomes answer in the sample space. Example: probability of rolling a number less than 5 on a die. There are 4 possible answers in the sample space, 1, 2, 3, 4. Probability of flipping 2 coins and getting at least one head. There are 3 possible answers in the sample space, head head or head tail or tail head. Mutually exclusive events. When determining if events are mutually exclusive, you are looking for any sharing of elements. Two events that have no outcomes in common are called mutually exclusive. These are events that cannot occur at the same time. When two events A and B are mutually exclusive, the probability of A and B, or probability of A intersect B, equals 0. Remember that "and" implies intersection of the sets. Mutually exclusive sets will not intersect or overlap. For any two mutually exclusive events, the probability that an outcome will be in one event or the other event is the sum of their individual probabilities. So, if A and B are two events are mutually exclusive events, so probability of A or B or union equal probability of A plus probability of B. The addition rule, or The addition rule of probability is used to find the probability of that event A or event B happens. Examine or union. In probability, an outcome is an is in event A or B when the outcomes is in either or both event A and event B union. So OR is associated with the concept of union, combining together. So the notation union is used for OR union. Probability of A or B is same as probability of A union B. Rule of OR for OR may be referred to as probability addition rule. Probability of A or B equal probability of A union B equal probability of A plus probability of B when A and B are mutually exclusive. But when A and B are not mutually exclusive, elements may overlap. Probability of A or B equal probability of A union B equal probability of A plus probability of B minus probability of A and B. Example: a die is rolled. What's the probability that the number is a 4 or the number is a 1? So the sample space is 1, 2, 3, 4, 5, 6. Event A is number of the die is a 4, so the probability of A is 6. Event B is number on the die is 1, so the probability of B is also 6. These outcomes don't overlap. They are mutually exclusive. From the diagram, we can see that there are two values that are in A or in B. So probability is 2 over 6 equal third. Using the formula probability of A or B union equal probability of A plus probability of B. Probability of A is 6 plus probability of B is 6, so it equals 2 6, so equals third. A die is rolled. What's the probability that the number is even or less than 4? So sample space is 1, 2, 3, 4, 5, 6. Event A is numbers on die that are even, which is 2, 4, 5, 6. So the probability of A is 3 over 6, 6. Event B, numbers on die less than 4, which be 1, 2, 3. So the probability of B equal 3 over 6. Because the overlap, the two will be counted twice when the sets are combined. We must subtract one of these occurrences. From the Venn diagram, we can see that there are 5 values that are in A or in B, with the two occurs only once. So the probability will be 5 over 6. How? Using the formula probability of A union B equal probability of A plus probability of B minus probability of A intersect B. So probability of A is 3 over 6 plus probability of B is 3 over 6 minus probability of A intersect B is 6. So and finally is equals 5 over 6. Complement of an event. Not. If A is an event within the sample space S of an experiment, the complement of A, which may be written as A exponent C, consists of all outcomes in S that are not in A. Other possible notations of complement of an event is A exponent C or A dash or A bar or A slash. The complement of A is everything else in the problem that is not in A. Definition: the probability of the complement of an event is 1 minus the probability of the event. So, probability of A exponent C, that's mean complement, equal 1 minus the probability of A. Since the sum of probabilities of all possible events equal 1, the probability that event A will not equal is equal to 1 minus the probability that event A will not occur. Here, example 1. A pair of dice are rolled. What's the probability of not rolling doubles? So there are 6 ways to roll doubles. 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. So probability of doubles equal 6 over 36 equals 6. So probability of not doubles will be 1 minus probability of doubles 6 is equal 5 over 6. Independent events. Two events are said to be independent if the result of the second event is not affected by the result of the first event. So the probability of one event doesn't change the probability of the other event. So if A and B are independent events, the probability of both events occurring is the product of the probability of individual events. So if A and B are independent events, so probability of A intersect B equal probability of A and B, that means equal probability of A times probability of B. This is referred to as the probability multiplication rules. Example 1. What's the probability of tossing a head on a penny or coin and then choosing an egg from a standard deck of cards? So these are independent events as the second event is not affected by the first. So the probability of both of these events is found by multiplication rule. So the events are independent. So probability of head then egg, so it equals probability of A times probability of egg. Probability of A of head equal half times probability of egg is 4 over 40 4 over 52, that's equal 2 over 52, and that we simplify by 1 over 26. Dependent events. If the result of an event is affected by the result of another event, the events are said to be dependent. If A and B are dependent events, the probability of both events occurring is the product of the probability of the first event and the probability of the second event once the first event has occurred. So, if A and B are dependent events and A occurs first, so probability of A and B intersect equal probability of A times probability of B. So probability of A intersect B equal probability of A and B equals probability of A times probability of B given A. The notation probability of B given A is called conditional probability and is read the probability of event B given that event A has occurred. So a bag contains 3 green marbles and 2 red marbles. A marble is drawn, not replaced. So, and then a second marble is drawn. What's the probability of drawing a green marble followed by drawing a red marble? By not replacing the marble after the first draw, the probability of the second draw is affected. So, the sample space with the second draw has changed, leaving only 4 marbles. The events are dependent. So, the probability green then red equal probability of green times probability of red given green occur equal, so probability of green is 3 over 5 times probability of red given green occurred equal 2 over 4. That's equal 6 over 20. We simplify by 3 over 10. Conditional probability. The conditional probability of an event B is relation to event A is the probability that event B will occur given the knowledge that an event A has already occurred. Notation of conditional probability is probability of B given A is read the probability of B given A. So if event A and B are independent, where an event A has no effect on probability of an event B, then conditional probability of event B given event A is simply the probability of event B. So probability of B given A equal probability of B where A and B are independent. If events A and B are dependent, where event A has effect on probability of event B, then we saw the probability that both events occur is defined by probability of A intersect B equal probability of A times probability of B given A. Dividing both sides of this equation by probability of A gives us our formula for conditional probability of event B given an event A, where event A affects the probability of event B. So, probability of B given A equal probability of intersect over probability of A, where A and B are dependent. Here example, a bag contains 12 red M&Ms, 12 blue M&Ms, and 12 green M&Ms. What's the probability of drawing two M&Ms of the same color in a row? So there are a total of 36 M&Ms in the bag. You draw a blue M&M, look at it, and then eat it. There are now 11 blue M&Ms remaining in the bag. So there are 35 total M&Ms now remaining. You will now need to draw another blue M&M. So the conditional probability will be probability of draw blue M&M given first M&M and blue equal 11 over 35. Using the formula, probability of A and B equal 12 over 36 times 11 over 35, and probability of A is 12 over 36. So probability draw same as first color M&M given first M&M color equal probability of B given probability of A. That's mean equal probability of their intersect, this one, over probability of A, this one, then we will get 11 over 36. Here another example, in a school of 1,200 students, 250 are seniors, 150 students take math, and 40 students are seniors and also taking math. What is the probability that a randomly chosen student who is a senior is taking math? These questions can be confusing. It sounds at first read that they are asking for the possibility of choosing a student who is a senior and who is taking math. Not quite right. So it helps to reword the question into find the probability that the student is taking math given that the student is a senior. So B is the student is taking math, and number of A, the student is a senior, is 250, and number of A and B, the student is a senior and is taking math, is 40. So probability of B given A equals probability of A and B over probability of A. So probability of A and B 40 over 250. That will give us 16%. The answer is not 40 over 1200, because we already know that student is a senior. And this diagram shows explain more about this example. Here, last example, let's examine a two-way frequency table to see how conditional probability will apply. Remember our example on whether 240 people surveyed preferred a sport Italy vehicles or a sport a car. So here male female total sport, about 21 males they like sport utility vehicle, and 39 males like sports car, and total who like both they are 60. And here about 135 females that they like sport utility vehicles, and 45 females they like sports car, and the total of females is 180, and the total of all male and female who like sport utility is 156, and all people who like a sports car, both male and female, is 84, and here the total is 240 people. What's the probability of choosing a sport car given that the person is a male? We need to find a probability of sport car given male. So now probability of male is 6 over 240, that's equal 2.25. So the probability of sports car equal 84 over 240 equal 0.35. So but probability of sport car given male equal 39 over 60, that equals 0.65. Remember that we know that the person is male, so the probability is the number of males choosing a sport car 39 divided by the number of males. What if we reverse the order? So what's the probability of being a male given the chosen vehicle is a sport car? So we need to find a probability of male given sport car. So now probability of male equal 60 over 240, that's equal 0.25, and the probability of sports is equal 84 over 240 equals 0.35. Now but probability of male given sports car equal 39 over 84, that's approximately equal 0.46. Remember that we know the chosen vehicles is sport car, so the probability is the number of males choosing a sport car 39 divided by the number of sports 84. At this lesson we finish this video, and thank you for your listening.